Welcome to this video on the topic of radicals. In this video, we'll be going over the concepts of squaring and rooting numbers. Now, first things first, we ask ourselves, what is a squaring operation? And the answer we have for that is the squaring operation is simply the process of multiplying a number with itself. So if we apply this understanding, then we have 1 squared. We simply write that as 1 multiplied by 1. And 1 multiplied by 1 is simply 1. 2 squared, we go 2 multiplied by 2, and we get a resultant value of 4. 3 squared can be rewritten as 3 multiplied by 3, and the result of that is 9. Similarly, skipping the step of multiplying everything together, we go 4 squared is simply 16. 5 squared is 25. And 6 squared is 36. Now, at first glance, this doesn't look very interesting at all because all we're effectively doing is multiplying numbers, and we've assigned it a operation that doesn't seem that complicated, or rather that helpful. But the interesting thing is the geometric pattern that can be arranged when we have the results of these squaring operations here. So what I've got down here is I've got the numbers 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. And what I've gone and done is I've represented them geometrically. So if you have 1 squared, you have a single dot on the page, and it can be written as 1. So 1 squared results in 1 dot. 2 squared results in 2 dots by 2 dots, and that yields 4. So what you end up finding is that you have a total of 4 dots. Similarly, 3 squared is 3 dots across, 3 dots down, that's 9 dots in total. 4 squared, that's going to be 4 dots across, 4 dots down. You have a matrix of 16 dots. And finally, 5 squared will give you 25 dots in total. Now, once again, this doesn't look all that interesting. However, the arrangement of these dots allows us to go not in the squaring operation direction, because that's a nice easy operation to do, but rather how we can go backwards. What we can do if we have a square number and we want to calculate the original amount that we had to multiply together to get the square number here. So suppose if we had 9 and we wanted to go in reverse back to what number multiplies by itself to give 9. Well, we simply count the height, or we count the width of this geometric representation. So the numbers that can be arranged in squares, we call those square numbers, and the resultant number we get by counting the side lengths, we call that the root of our square number. So going down, we can say the square root is the opposite of the square operation. It is represented with the radical symbol root x. So this green symbol over here. Now moving across, what we're going to do is we're going to have a look at some calculations. So suppose we have root 1, root 2, root 3, and we want to calculate all of these. Now, looking at these, if we represent our numbers as dots, it's a nice simple operation to go backwards from. So for the square root of 1, we know that that's going to be equal to 1 because 1 times 1 is simply 1. The square root of 2, though, I'm not too sure, so I'm going to leave that for now. Square root of 3, not too sure either. However, square root of 4 here, if I want to calculate this, I can look back at my geometric representation, and I've got 4 dots. If I count the width, or the height of these dots, I get a value of 2. So I know the square root of 4 is going to be 2. Square root of 5, well, I can't really see a pattern over here, so again, I'm going to leave it. But the square root of 9, I know that that's 3 dots across and 3 dots down. So the square root of 9 will be 3. 16 will be 4. 25 is going to be 5. And 36 is going to be 6. But this leaves me with these 1, 2, 3 unknowns here. And one way you can do it is you can guess. So you know the square root of 2 is going to be between 1 and 2. Or you can use your calculator. And then we take it and we get 1.41. Square root of 3, 1.73. And square root of 5, is going to be 2.3, 2.24 rounding upwards. So roughly 2. So what we find from this is that taking the square root of a square number yields an integer result. So 1, 4, 9, 16, 25, and 36 are all square numbers. In contrast, square root of a non-square number yields an irrational number. So non-square, we have root 2, root 3, and root 5. So these guys give us irrational numbers, numbers that never really end. Typically, for such a situation, when we are calculating these numbers here, if we're working with a non-square number, we simply leave it in its root form. So typically such irrational numbers are left in their radical form, so the square root of it. So rather than representing it as 1.41, I'd simply leave it as the square root of 2. Or if my result was the square root of 5, I'd leave it as the square root of 5. So this has been a video explaining the square and the root operations and how we deal with these irrational numbers.